What's up, ladies and gentlemen, boys and girls? This is Mr. Richardson coming at you live through the power of the internet. What we're going to be doing today is factoring, specifically trinomials, where the a term does not equal 1. Now, in a previous video, we had learned how to factor trinomials where the a term equaled 1. This is a little bit different. And a spoiler alert, in order to do this method, you're going to need to know how to use factor by grouping. So if you haven't used factor by grouping yet, go back, watch that video, come here when you're done. Let's take a look at the notes on how to do this method. First step is to put the trinomial in standard form, meaning your x squared term should be first, followed by your bx term, followed by the constant. The next step is kind of similar to what we've done in the past. You want to find two terms that multiply to a times c and two terms that add to b. Now in the past, we had found two terms that multiply to c. Well, what you were really doing in the past was actually finding two terms that multiplied to a times c, like we'll do now, but the a term was always 1. So it's kind of what you've been doing. Step 3 is a little bit different. What you're going to do in step 3 is you're going to replace the bx term, the piece right here, with two bx terms that use the numbers that you found in step 2 as coefficients. And after we've done that, what we'll have is 4 terms, and we'll factor by grouping. Let's look at an example. I want to factor this trinomial here. Notice that the a term is not 1, it's 6, and when the a term is something other than 1, it makes it very difficult to factor. So the first thing I want to do is find two terms that multiply to a times c. Well, a here is 6, c is negative 6, so I want to find two terms that multiply to negative 36 and add to b, which is 5. When I think about what numbers do this, they have to be a factor pair of 36. They have to add to 5. To me, it looks like it's going to be positive 9 and negative 4. When I find those two numbers, the next step is going to say, replace the bx term with two bx terms that use the numbers from step number 2 as coefficients. So the negative 4 and the 9 represent negative 4x and 9x, and what I'm going to do is replace 5x with negative 4x and 9x like so. Notice that negative 4x plus 9x just equals 5x. So I actually haven't really changed the value of the expression, I've just changed the way it looks. Once I've done this, I now have 4 terms and it's reduced to a type of factoring we know how to do, which is factor by grouping. To factor by grouping, take the 4 terms, split them into 2 pairs. Next step, find the GCF of each pair. The GCF of the first pair, 6x squared and negative 4x, is 2x. When I divide 6x squared by 2x, I'm going to get 3x. And when I divide 4x by 2x, I'm going to get 2. Now, if you recall, in order to do factor by grouping, you need to get the same binomial, 3x minus 2, when I take the GCF out of the second pair. Well, the GCF of 9x and 6 will be just positive 3. And if I do this correctly, 9x divided by 3 is 3x. 6 divided by 3 will be 2. I can see that the binomials match. I'll factor out the shared binomial. 2x plus 3 will become one of my binomials, and 3x minus 2 is the other one, leaving this in factored form as 2x plus 3 times 3x minus 2. Now, there is one step here that can be confusing for students. It's the order that I place these terms, the negative 4x and the 9x. Technically, you have two options when you replace the bx term with these two terms. What I recommend doing is replacing it in an order that the binomials match. For instance, if I look at this binomial, it's a positive term and then a negative term. And here I have a positive term and a negative term. Let's say I had changed the order and put the 9x first and the negative 4x second. Well, if I had done that, I'll still get the same answer, but I believe it's a little bit more challenging. The reason is my pairs don't match now. Here I have two positive terms, and they don't match the other binomial because they're two negative terms. So what ends up happening is I have to factor out a negative term out of the second binomial in order to get the signs to match. I'll show you what we mean. 6x squared and 9x have a GCF of 3x. When I divide those, I'm going to get 2x plus 3. In order to get left over with 2x plus 3, these are both positive terms, I'll have to factor out a negative number out of this binomial. The negative GCF here would be negative 2. And if I do that, I will be left with 2x plus 3. You can see that we do get the same solution. Let's see if you can try one on your own. See if you can factor this trinomial. First step is I need to find two numbers that multiply to a times c. 8 times negative 3 is negative 24, and then those same numbers have to add to 10. Well, if they multiply to a negative, it needs to be one positive and one negative. Looks like this pair will be 12 and negative 2. Use those numbers now to replace the bx term with negative 2x and 12x. I'll place the negative 2x first, so my binomials match with the same signs. For instance, it goes positive, negative, positive, negative. Now just factor by grouping. Split the four terms to form two pairs. The GCF of the first pair of 8 and 2 is 2, of x squared and x is x. Divide 8x squared by 2x, we get 4x. 2x by 2x, we get 1. I need to get this same binomial, 4x minus 1, to make this work. The GCF of 12x and 3 is positive 3. When I divide 12x minus 3 by 3, I do get 4x minus 1, meaning when I factor, it's 2x plus 3 times 4x minus 1. If I want to check this solution to see that it's correct, all you have to do is double distribute or FOIL, and you can see that this factored form is equivalent to this standard form. Let's try another example. See if you can factor this trinomial expression. First step, find two numbers that multiply to a times c and add to b, or multiply to negative 24 and add to 5. Because they multiply to a negative, it needs to be one positive and one negative. This should be positive 8 and negative 3. I'm going to replace the bx term 5x with negative 3x and 8x. When I replace them, I'm going to put the negative term first and the positive term second, so that my binomials go positive, negative, positive, negative. Now factor by grouping, find the GCF of each pair. The GCF of the first pair is 3x, leaving me with 4x minus 1. I need to get 4x minus 1 as the binomial when I factor out this GCF. The GCF of 8x and 2 is just 2. When I divide 8x by 2, I do get 4x, and 2 by 2 is 1, leaving me with the factored form 3x plus 2 times 4x minus 1. Let's try another example. See if you can factor this trinomial. Find two terms that multiply to a times c, add to b. A times c is negative 90, add to b is negative 1. Whenever my terms add to 1 or negative 1, it means they have to be consecutive because they're only apart by 1. The two consecutive numbers that multiply to negative 90 are negative 10 and 9. Replace negative 1x with negative 10x and positive 9x. Factor by grouping. Split the four terms to form two pairs. GCF factor each pair. The GCF of the first binomial looks like it will be 2x. When I divide this binomial by 2x, I'm left with 3x minus 5. I need to be left over with 3x minus 5 when I find the GCF of the second binomial. The GCF of 9x and 15 is 3. And I am left with 3x minus 5, leaving my factored form as 2x plus 3 times 3x minus 5. If I want to check my answer to make sure that this is the correct factored form, I can double distribute, commonly known as foiling, to make sure that this factored form is the same as the standard form. Let's try one last example. Here I want to factor this last trinomial. Find two terms that multiply to a times c, or 21 times negative 5, and add to b, which is negative 8. Multiply to negative 105, add to negative 8. I find those numbers, it's negative 15 and 7. Replace the bx term with two bx terms that use these numbers, so meaning replace negative 8x with negative 15x and 7x. Now just factor by grouping. Take the four terms, split them into two pairs. GCF factor each pair. The GCF of the first pair looks like it will be 3x. Dividing 21x squared by 3x gives me 7x minus 5. And if you look, I have 7x minus 5 here. This binomial already is 7x minus 5, so I must have to factor out a GCF of just 1, which will leave me with 7x minus 5, making the factored form 3x plus 1 times 7x minus 5. If I want to check my solution, I can simply double distribute or FOIL to see if this factored form is equivalent to this standard form. I hope this video has helped you figure out how to factor trinomials where a does not equal 1. I'll see you next time.